All right, so the first blank is going to be steepness, okay? Slope measures how steep the line is. Okay, and then there are 4 different types of slope. A positive slope, your line is going to be uphill. Negative slope, it should be going downhill. And then for Hoy and Vux, those are just acronyms to help you remember a 0 and an undefined slope. So for Hoy, does anyone happen to remember what the H stands for? Horizontal, very good. Okay, the 0 is the type of slope. And the equation will be y equals, and then a number. So most lines are going to follow the pattern y equals mx plus b. But if it's a Hoy or a Vux, it's just going to be y equals or x equals. Okay, horizontal runs perfectly flat like that. Okay, Vux, what do you guess the V stands for? Vertical. And then U is the type of slope. Do we remember what that word should be? Undefined, very good. Okay, because it's not uphill or downhill or flat. It's going to be perfectly vertical like that. And then Vux, the X is going to be X equals a number. So essentially, if it's a Hoy or a Vux, you're going to find that number on that axis and then draw in either a horizontal or a vertical line. So go ahead and take a look at those bottom 2. For y equals 4, is that a Hoy or a Vux? It's a Hoy, very good. So you're going to go to 4 on the y-axis. And then you're going to draw in a horizontal line, which should look like this. Okay, for number 2, it's x equals, is it a Hoy or a Vux? Vux. So then I'm going to go on the x-axis to -2, and I'm going to draw in a vertical line, which should look like this. So -2 is here. And then sketch in your line, that should look like that. Okay? All right, once you've got those 2, go ahead and turn the page. Okay, if it's only a y or only an x, it's a Hoy or a Vux. Okay, but most lines are going to follow the format where you have both. Okay, you'll have y equals and then mx plus b. Okay, m is going to be your slope. And b is going to be your y-intercept. Now, the parent function is just going to be the general equation, but with no extra numbers in it. So your parent function is just going to be y equals x. Or you're not going to have a specific slope written in, you're not going to have a y-intercept written in. And your linear parent function is going to cross at 0. And then it's going to have a perfect diagonal slope. So if you just want to draw a few dots this way, and then a few dots this way. Okay, but your parent function should be a perfect diagonal line. Now, once I work numbers into the slope and the y-intercept spots, it's going to change what that graph looks like. So let's go ahead and do numbers 2 and 3. Okay, you're always going to start with the b. Okay, so I usually will say like you're going to begin with the b, kind of cheesy, but then once you find that start point, you're going to move according to what the slope is. So for my number 2, this is my M. This is my B. Where am I going to begin at? What number? 6. Now, because this is a y-intercept, you're going to find 6 along the y-axis. So my y-axis is here. You can see it kind of written in really small. Put your dot right there. Now, your slope is going to define how steep the line is. Okay, so we're going to rise over run with the 1/2. So I'm going to rise 1 and run 2. So from that dot that you placed at 6, you're going to go up 1 and run forward 2. Up 1, forward 2. Okay, then connect those dots. Now, you'll notice that for number 3, you have your X, but remember, X is the M. Your B is missing. If there's not a B, that means that you're going to stay where the parent function hit. So go ahead and write in a +0, meaning that my B is not being changed. So this is my M, and my B is a 0. So place a dot on 0. That's where I'm going to begin, because that's my B. And then my M, or my slope, is just -3. Now, if this number happens to be a whole number, what can I put it over so that it's a fraction? Over 1. Very good. So I'm going to rise -3, and then I'm going to run 1. So starting at your dot that you placed at 0, you're going to go down 3 because your rise is negative, and then you're going to run forward. Okay, your run should pretty much always be forward. So go down 3 again, forward 1. Down 3 again, forward 1. Okay. All right, then for both of these graphs, okay, we talked about positive and negative slope. Okay, another way to describe these would be increasing and decreasing. Increasing means you have a positive slope. And which of those graphs is increasing, the first one or the second one? First. So this would be increasing because it has a positive slope. Okay, versus your second line, you would consider it decreasing because it has a negative slope. Okay, but you want to make sure that when you're tracing the line, you want to start on the left-hand side. So this one, I can tell I'm working my way uphill. This one, I can tell I'm going downhill. But remember, you want to be pushing forward when you're checking that. Okay, any questions on that? All right, for those bottom 2 blanks, a stretch means that your graph got steeper. And a compression means that your graph got flatter. So if I'm looking at those 2 graphs that I just did, remember the parent function is a perfect diagonal. Would this graph be an example of a stretch, meaning it got steeper, or a compression, meaning it got flatter? It would be a compression because remember the original slope is a perfect 1 diagonal. So if I change it to a half, that's going to kind of flatten it out. Okay, versus this one, if my perfect diagonal's here, then I can see that it tilted steeper. That would make it a stretch. Okay, but we'll do more with that next time. Go ahead and turn the page. All right, the second parent function that we're going to do is absolute value. Does anybody remember the shape for an absolute value graph? It's okay, it's a V. Okay, so go ahead and write the equation at the top. Remember that your parent functions don't have any extra numbers in them. So it's just going to be the X and then the bar symbols around it. Put your first dot at 0. And you're going to go perfectly uphill. But then you're also going to go up on the other side to create a V shape. So absolute value is going to be a V shape. Now, as we place numbers in different spots in the equation, it's going to change the parent equation. So we're going to focus on the number inside the bars and then the number at the back. The number inside the bars with the X is going to shift your V either left or right. Okay, however, because that number is packaged in the bars with the X, you're always going to do the opposite direction of what it says. So if it gives you a plus, you're actually going to go to the left. If it gives you a minus, you're actually going to go to the right. So I'm going to put here opposite direction. The number at the back of the equation is going to shift your graph up or down. And because that number is not inside the bars with the X, you're going to do same sign. If it says plus, you're going up, minus, you're going down. So once you have that written down, let's take a look at our first graph that we're going to do with numbers mixed in. Okay, we're looking at graph A. I have a -5 in the bars, but it's with X. So am I going to go right or left? Right is correct, because if it's a minus, okay, then I really want to go forward. So I'm going to put a little arrow here to the right 5. And then my +3, that's in my up or down number. Which way are we going to go? Up. Very good. So on your graph, start at 0, 0, go to the right 5, and then up 3. Then from there, you're going to make your V, but remember, it should be perfect diagonals on both sides to make that shape. So I'm going to go up this way and then up this way. Okay, once you've got that one, take a look at your next graph. I want you to put the arrows which way it's going to move. So I have a +2 on the inside and a +4 at the back. So for the +2 on the inside, are we going left or right? Okay, left. Good. And then the +4? Up. So I'll go left 2, up 1, 2, 3, 4. Now, normally my V opens up. Will that be the case for this one? No. What is going to change that? Okay, very good. So I'm going to put a little arrow. Okay, this is going to reflect your V upside down. Okay, or have y'all used the abbreviation ROCSA? So that's reflect across. If you like that abbreviation, that's fine. So instead of my V going up perfect diagonals on both sides, it's going to go down perfect diagonals. So I'll go here and then here. Just like that. All right, we have two more left like that. Let's take a look at numbers. Letter C. I have a -6. Which way are we shifting? Left, right, up, or down? To the right. What about the -3? Down. So go to the right 6 and down 3. Okay, then for this one, I have a number in the front. Okay, this number is going to adjust my slope where it won't be a perfect diagonal anymore. But remember, slope is rise over run. So if it's a 1/2, you're going to rise 1 and run 2. So I'm going to go up 1 over 2. Just do your best since we kind of ran out of boxes there. Okay, up 1 over 2. And then I'm going to go back to the center and copy that same slope going to the left. So I'll go up 1 and over 2 this way. And then up 1 over 2 this way. Now remember, my parent function has a slope of 1. So if I change it to a 1/2, that would be considered a compression. Okay, which we're going to focus on more next time, but just so you're kind of thinking about it. Okay, last one like that. Take a look at letter D. I have a +5. Am I going up, down, left, or right? Up is correct because it's not in the bars. That means it's not side to side. Okay, my +5 is going to move my graph up. So go 1, 2, 3, 4, 5. Normally, my V opens up at a perfect diagonal. How will this one open? Down. So the negative is going to flip the V, and then the slope is going to be rise -2, run 1. Okay, remember that if your bottom number is missing, you can just put a 1. So starting at the top of your V, you're going to go down 2, run 1. Down 2, run 1. And then copy it on the other side. Okay. We're not going to get into domain and range today. We're just going to sketch the graphs. So once you've got those two, you've done 2 out of the 4 parent functions that we're covering today. So you should be able to do lines and V's. Turn the page when you're ready. All right, the next family that we're going to do is the quadratics. This is going to be y = x². Okay, and this is going to be a U shape. Now remember, all the parent graphs are going to start at 0. So you can already go ahead and put your first dot right there at the center. In order to make it a U instead of a V, you're going to go over up 1 and then over again up 3. So your first jump is going to just be 1 box. And then your second jump, you're going 3 higher. And then copy that on the other side. So it'll be a 1 jump first, then a 3 jump second. Now, one thing that does make this a little bit easier is that none of the jobs are going to change as far as what those numbers do. This number in here with the X is still going to shift your graph left or right. And it's still going to be the opposite direction of what the number says. So if it says plus, you're really going to the left. If it says minus, you're really going to the right. And then what did that back number do? Shifts it up or down. Good. And then remember for that one, you're going to do whatever the sign says. So if it says plus, go up, minus, go down. Okay. So once you have that, let's run through those graphs. Take a look at the first one. What number is with the X in the parentheses? Right here. -2, and if it's a -2, I'm really going to the right 2. Okay, then -5, I'm really going down 5. So right 2, down 1, 2, 3, 4, 5. But then remember, I'm copying this exact same shape. So remember, I jump 1 the first box, and then I jump 3 for the next stop. So you can watch me do it first, then do it on your paper. It's going to be over, up 1, over, up 3. Other way, over, up 1, over, up 3. And then that's your U. So the 2 and the 5 don't change the shape. They just change where the shape is. One more like that. Take a look at letter B. Which way are we going to shift the +2? Left, right, up, or down? Left. And the +4 is going up. So go left 2, up 1, 2, 3, 4. And then remember, unless they put a number in the front to change the slope, you're copying that exact same shape. So your first jump is 1 box. Your next jump would be 3 boxes, which we'll have to use our imagination. So over, up 1, over, up 3. Okay, last one off this page we're going to do is letter D. Okay, just to shorten these up a bit. So we're skipping C, go to D. I have a -2. Am I going left, right, up, or down? With where this -2 is. Which way? Down. Down is correct. So go down 2. And now you'll notice that normally your U opens up, but because I have that negative in the front, just like the V, it's going to flip it upside down. So you're going to do the exact same shape, but instead of going up 1 and up 3, you're going to go down 1 and down 3. So it'll be over, down 1, over, down 3. Over, down 1, over, down 3. Okay. All right, once you've got that, go ahead and go to the last parent function. So you should be able to do lines, V's, and U's. Okay, the last one we're covering today is the square root parent function. So turn the page. And I'll give you the parent function first. Okay, remember, parent functions don't have a bunch of extra numbers in them, so it's just the square root and the x in the equation. Just like all the other parent graphs, it's going to start at 0. Okay, but then your square root function, I call it a hook, just because I don't really know what else to call it. Okay, but you're going to go up over 1, up over 3. So it's kind of like the U, but it's like sideways. And then this graph doesn't have another side. It's just that little hook. So that's the only piece you have to worry about. Okay, then for all these numbers here, the jobs stay the same. So I'm not going to fill them out again. We're just going to go to the first example. So I have a -2 in the square root with the x. Which way are we going? Left, right, up, or down? To the right. What about the +1? Up. So I'll go to the right 2, up 1. And then this is where my hook is going to start from. But I'm going to copy that exact same shape from the parent graph. So I'll go up over 1, up over 3. So it's kind of like you're just taking that shape and copy and pasting it somewhere else on the graph. Okay, for this next one, really the 8 is too big. Let's just change it to a 1 so we're not like way off the graph. So for the +5, which way are we going to shift? To the left. And then for the -1, because we're changing that number, are we going up or down? Down. Very good. So go to the left. 1, 2, 3, 4, 5, down 1. And then remember, because it's a square root, it's still your hook shape. So you're going to go up over 1, up over 3. All right. Next one, let's change this 7 to a 2 so that it'll fit on our graph. Which way are we going to move the 2? Up, down, left, or right? Up. So go up 2. And then normally, okay, I'm going to sketch this in yellow. If you're writing in pencil, maybe try to draw it like really light. But you would go up over 1, up over 3, and that would be your hook, right? Okay, what is going to change how this hook looks in the equation? The negative, and remember, the negative flips it down. It doesn't flip it backwards, it flips it down, just like the U flipped upside down. So your U for this one is going to be down over 1, down over 3. Okay, so because of the negative out there in the front, it's going to take your original hook that you see there in yellow and it's going to flip it this way. Okay. Now, what do you notice in example D with the placement of the negative? It still has a negative, but it's not in the front. Do you see how it's on the inside? Okay, that is going to flip your hook backwards. That doesn't happen on your homework, so we're not going to do it. But I just want you to write a little note. Okay, this does still flip the graph, but it flips it backwards instead of upside down. But that case will not come up on your homework today, and we'll cover that one later. Okay? All right. So we only have 2 questions left. So if you'll turn to the last page. Okay, we are not going to do this page right now. I'm going to have you start on your Delta Math, and then in like maybe 30 minutes, maybe a little bit less, we'll hit these 2. Okay? So take out your computers. You should have made your Delta Math account last class. And then once you have it pulled up, we're going to do 2 questions together. We're going to start with the 4th question. I'll wait you to tell but for now, maybe we'll talk. Okay, so we're going to do the 4th question together. It should look like that. Everybody's 4th question should be the same. And you should be on homework 2A for parent. Yes. We're on the 4th question from the top. All right, taking a look at the 4th question, I see a +5 in the parentheses. Which way do I want to shift? Take the green dot. You're going to click and drag to the left 5. Okay, then the -1, what am I going to do with that? Down 1. Now, this is how you're going to submit it. So don't do anything else, but let's pretend you had to flip it. What you would do is take this blue dot, okay, right next to it, and you would drag it from up 1 to down 1. And then do you see how it'll flip it for you? Okay, obviously for this one, don't do it because it doesn't have a negative, but you could get one that does have a negative in the future. Okay, so for this one, it was left 5, down 1. Okay, then hit submit. The next question we're going to do is 7 from the top. So this is 4, 5, 6, 7. It's the first of the transform functions mixed. Now, one thing I want to point out to you is that you see the bars, okay? And in the notes, we talked about that that's a V, but it's not going to trick you. It's giving you the right V shape to start with. Now, what does the 1/3 do to the graph? Okay, it does change how it moves. Does it shift it left, right, up, down, or the slope? Rise 1, run 3. Now, this dot is already rise 1, run 1. So I just want to slide that dot over so that it's rise 1, run 3. But it's already up 1 and already over 1, so you just need to slide it 2 more. Does that make sense? Yeah. Okay. Am I going to move the green dot to change where the middle of it is? No, because it doesn't have any extra numbers. But if it does have both, you do both. Get the idea? Okay. You are not going to do the last 3. Everything else, though, you can do. Okay? No, but it follows all the same. So just move the green dot. Okay, so do that highlighted stuff right there. G3. You do have to make a little dash. 4, 5. And then N8. And then you can skip homework while I choose what you Now listen, if you get a cubic, we didn't cover that shape today, but the rules are the same. So just slide it the way that you know that you should slide it based on other things. Yes. Okay, start it over. It's only going to flip if there's a negative. So you have a +1, then you want to take that green dot and shift it to the left. Yep, just one. Yep. Perfect.
Oh, okay.
So it's still your hook shape, you're just dragging it to the left.
Okay.
Were you trying to move the blue dot?
I was trying to move the blue dot.
Yeah. Yeah, if you're moving the whole shape, use green. Yes. Sure. Okay, so you have a -4 in the parentheses. Is that an up, down, left, or right? So grab green and move it towards the right. The 2 is what makes the shape, but it's never going to give you the wrong shape.
That's what you said.
I'm sorry. Didn't want to embarrass you too much, but I saw it on focus. Yes. That's perfect. If you went up 5, that's exactly right. Okay, thank you. It's just on 5. On it. We're about to though, and then you'll be able to do those. That's okay. All right, go ahead and finish up the one you're working on. Then we're just gonna hit that last page of notes, and then you have the rest of class to finish up those last 3 questions and whatever else you need to work. So then for that line, yep, just done. All right, so for your last 3 questions, they're multiple choice, and you're gonna have the original shape and then where they moved it to, and you're gonna be asked to pick which equation is correct. So if you're looking at this one, what is the first thing that you notice about the original hook and the new hook, the dotted line? It's flipped. And in order to flip it, what do I have to put in the very front? Do you remember? A negative. Okay, then I noticed that not only did they flip it, but they also shifted it where instead of the hook starting at 0, it starts at -3. So I'm going to put an f of x with a +3. So the +3 is what shifts it to the left. The minus is what flips it. And for those questions, when you do them on your homework, they're multiple choice. Okay? All right, one more like that. Okay, this time we have a shape we haven't done, but it doesn't matter because they all follow the same rules, right? So my original little son is here. And my new son is now here. So let's count how many boxes did it move. So this is the original. I want to map it to here. How many boxes do I need to go to the right? 4 is correct. So I want to go to the right 4. And then I have to shift it down. How many? 3. So if I want to go to the right 4 and then down 3, I'm just going to take those numbers and put them in my f of x. So it's going to be f of x. If I want to shift it to the right 4, what type of 4 do I put with x? A minus. Very good. Because remember, the one with x has to be the opposite. So if I want it to go forward 4, I need to put a minus 4 here. And then to make it go down 3, I would just put a minus 3 at the back. Okay. So when you get to those last 3, you're picking multiple choice. Remember, the negative in the front flips it. With the x's side to side. And then at the back shifts it up or down. Okay? All right, you have about 30 minutes. If you have to go to the bathroom and it's full, I'm happy to write you a bathroom pass, but try and finish up all of today's assignment so that you don't have anything left to do. Yes, sir.